very warm welcome to everyone who's joined us this morning for this webinar on intelligent test automation with Tricentis Tosca. On behalf of Tricentis and InfoChips, I'd like to welcome you. And I'm going to hand over the mic to my colleague Saurav, who is responsible for sales and business development in North America, and he's going to walk you through the agenda and introduce the speakers as well. Good morning, Saurav.
Good morning and thank you, Jaideep. Hello and welcome everyone to this webinar on intelligent automation using Tosca, jointly hosted by InfoChips and Tricentis. My name is Saurabh Joshi and I am a part of the team that brings innovative engineering solutions to InfoChips customers across the globe. We truly appreciate your time today and hope you'll take away some valuable insights from today's interaction. Our panel today, we have Bill Hayden, an IT industry veteran with specific focus on quality engineering, currently spearheading the continuous testing solutions for Tricentis. Gaurav Inamdar, who is a test automation lead at InfoChips, who has been instrumental in bringing value to various global projects across insurance, telecom, and healthcare domains. And Konika Negi, an expert in test automation, with an impressive track record across multiple tools and technologies, again with primary focus on functional and IoT testing. Today, our experts will address typical challenges in software testing and discuss how intelligent automation effectively addresses those against traditional approach. We also have a couple of interesting demos on vision-based AI and API testing. We encourage to post any queries, as mentioned by Jaideep, in the chat box of the GoToWebinar, and would be glad to answer those at the end of the session. To begin with, let me introduce you to InfoChips as a product engineering services arm of Arrow Electronics. With a strong parentage of Fortune 102 ranked world leader and 27 plus years of proven expertise of delivering scalable, sustainable, and innovative solutions, InfoChips is a one-stop shop for device, digital, quality, and silicon engineering. We provide concept to production solutions across 10 industry verticals. Having developed more than 500 products, we also digitally manage more than 100 million devices for our customers. 3,000 experts across the stack of technologies. We are perfectly poised to help our customers achieve their roadmap across device and digital engineering. Our quality engineering practice plays a pivotal role in bringing value to our customers through software testing, product testing, IoT testing, leveraging our solution accelerators and test automation frameworks. Our recent ecosystem partnership with Tricentis has been a real game changer for our customers. On this note, I'd like to hand it over to Bill to introduce Tricentis and dive right into today's topic without any further ado. So over to you, Bill. Let's get going.
Thank you so much for that great introduction and queuing up what is going to be a very exciting webinar. As we were putting this together, I was commenting that not even some of our own internal engineers have accomplished what the InfoChips team has accomplished today that you will see live and in person. But first, a note about Tricentis, and then I want to lay the groundwork for how the test automation world is evolving. As you could tell from my profile picture, I've been around for quite some time. That gray hair is well earned, and it gives me a very historical perspective on where we've been as an industry, and most importantly, where we're going and all the reasons I am currently at Tricentis. Now, why do we exist? Our founder, Wolfgang Plotz, said it very simply. Speed changes everything. If you think about the rate of change you're dealing with from your application environment to your testing efforts today is as slow as it will ever be again. And I want to walk through the struggles we've had as an industry and talk about how Tricentis and InfoChips are perfectly positioned to tackle those challenges. Because what it comes down to, and I could spend a lot of time on this slide, but I just want to draw your eyes to the results. 90+% automation coverage with positive ROI that's sustainable. I'm going to talk about that, which naturally leads to this increase in speed. And then the natural currency that we talk about is risk. Pure risk coverage, all the more important now that we're migrating so many systems to the cloud, increasing complexity 10, 20-fold. Now, next slide, please, because I really want to get into the meat of the matter. So let's look at traditional versus what we're going to call intelligent automation. We all came from a point, and I started doing this in the 90s, early on with some Apple OS macro recording tools, working my way up to that industry standard Windrunner 3 and Windrunner 4 back in the late 90s on the build up to Y2K. And at the time, they were very innovative solutions. Code-based, you had to know some sort of language in order to use them, programming or otherwise. But the biggest issue, and I won't go through each of these bullets, I want to draw your eyes to the third bullet on the left-hand side, the high maintenance and the inability to get a high rate of reusability. We were simply spending more time fixing things than we were running them. And that maintenance cost really called into question, are we really fulfilling the promise of test automation? Now you can see where we're headed, and I'm going to walk us through that in the next few slides. Intelligent test automation, what we want to get to, data-driven, being able to exercise machine learning as much as possible to take some of that burden off, going from a script-based solution to a model-based solution. So those are the directions that the industry is heading. But let me show you how we got there. So if we look at the reality of testing, there were 3 key indicators that came out of Capgemini's World Quality Report in 2019. This is pre-COVID. Believe me, since COVID and the headlong rush to the cloud, this has only gotten worse. Look at how much money we were spending on QA. And that's not just the line item for QA department, that's all quality, from the activities the developers were doing to operations, even the call centers. We were spending a good deal of our IT budget just trying to keep up with quality. At the same time, everyone was using that buzz term digital transformation. We needed to be more agile. We needed to get our ideas from the drawing board to our production customer facing systems as quickly as possible. And what was standing in the way of that? Testing. For some of the reasons we already talked about, our automation was not maintainable. And that led to automation rates dropping. In fact, in 2004, I believe, a gentleman named Charlie Lee wrote a book about where's that break-even point for script-based automation. Turns out it was 40%. Anything above 40%, we were simply spending more time fixing it than we were running it. Not really beneficial. Now, what's happened since '04? A lot. Agile revolution, DevOps revolution. You can see on the right here, the DevOps revolution, because of the increase in speed and the cadence, it dropped those break-even rates down to 20%. We still see this in a lot of customers. So what happened to the other 80? We're not just talking unit, we're talking end-to-end integration, all aspects that we could automate. Well, that's either not getting done or it's being done manually, hence why that testing bar is still so high. Now, next slide, please. So to quote Michael Bolton, not the singer, the author of Rapid Software Testing, and my colleague Danny Duvalli loves to quote Michael Bolton in all his presentations. The problem is not that testing is the bottleneck. Sometimes we don't even know what's in the bottle. Testing addresses that. Now, how are we going to address that? Next slide, please. So where were those bottlenecks? Where were those stumbling blocks? Why were we having so much trouble keeping up? And these are still very common. We already talked about the high frequency of application changes. Today's as slow as it's ever going to be again. But there was also this spread of tools, if you will, for different environments. We had the open source revolution that was mainly targeted for web-based interfaces, but we still had to maintain legacy tools for, I don't know, automating mainframe perhaps, automating some of those heavy clients, heavy Java clients, for instance. And that led to a spread of different teams with different skill sets, not to mention a higher level of skill set needed to use those open source tools effectively. We had too many tools. We didn't have the right tool for the job. We couldn't string together an end-to-end process that might span multiple systems with a single platform. And of course, as we got more and more complex test cases, how are we going to manage the environment, let alone the test data? And you can see this is also from the World Quality Report of 2019. But what if we had a platform that would address all of these and give you one unified testing approach, model-based, codeless, with machine learning enabled self-healing that one team could use on any application? Next slide, please. So as my founder Wolfgang said, and I quoted him earlier, in his book, Enterprise Continuous Testing, which I highly recommend to everyone, testing harder isn't the answer. Throwing power, time, effort, bodies at the problem is not the answer. We've got to test smarter. We've got to find a way to inject efficiencies into everything we do, whether that's doing intelligent analysis up front, so we're actually doing less testing more intelligently, whether that's using the most maintainable approach imaginable for our automation, so we get those high rates of coverage that you saw on a previous slide that's maintainable, and being able to leverage those artifacts, whether we're doing functional or performance testing. That was his mission for Tricentis. Next slide, please. And these are the results he achieved. 90% automated coverage rates. And again, the caveat that's missing here on this slide is with positive return on investment. We're not talking about spending more time fixing the problem than we are running the test. And if you think about where test automation has come from, all script-based solutions had that maintenance problem. I mean, you're literally building a secondary code base to test a primary code base. That carries with it inherent technical debt. So Wolfgang's first idea is let's take code out of the equation. Let's create a very visual model-based way to maintain, build, and run these tests. That does several things for us. It gives us a consistent approach across any application. It gives us a way to keep up with maintenance, and it actually requires a non-developer skill set in order to use. So now we can achieve these rates. And when I first came to Tricentis, I was dubious that this was possible until I talked to our customers. And they are indeed achieving 85 to 95% automation coverage rates that's maintainable. That leads to the speed factor. That leads to the risk coverage factor. And now with the release of Tosca 15, just last December, we have incorporated machine learning self-healing into the equation. And we are leveraging machine learning in one other different way as well, because I want to talk about how we've gone from script-based to model-based to true AI-driven automation. Next slide, please. So as I mentioned before, Tosca is our automated testing platform. It is an Italian word that means from Tuscany, also a play by the same name that our founder was very fond of. And it is a truly end-to-end model-based solution that incorporates machine learning, both in terms of being able to overcome difficult UI automation, as well as incorporate self-healing into changing UI automation. We don't stop at the UI level. Tosca is equally effective at the API level and the data integrity level as well. It also incorporates integrated test data management. It has the ability to optimize the different data combinations so that you're not running 500 different positive test cases and only one negative. It can tell you which combinations you need to run. If service virtualization is required, we've incorporated this into a very visual model-based paradigm as well. And as a result, we're seeing these high automation rates. Next slide, please. Now, what is a model? A model is a very visual representation of the screen of the application we're testing if we're doing UI testing. For API testing, it's literally the request response pair, REST or SOAP or what have you, but also represented very visually. For data integrity, it's that SQL statement and the returning data set. And to build these models, we have a variety of mechanisms. In this example, we're using something we call our X scanner, where when we launch it, we have it interrogate the application we're going to test, and Tosca immediately decides from its library of over 170 different technology drivers which driver is optimal for this. And that's seamless to the Tosca user. So whether you're testing web, SAP, Workday, mainframe, the end user experience is consistent. Right before this call, I was testing my iPhone, and it worked exactly the same way for mobile. And from those building blocks, that model, that picture of the screen with all the different objects we're going to touch, we're basically building a library of Lego pieces that we then snap together as test cases, which you see here on the right. Very visual, very easy for a business user to look at, by the way, and say, oh yes, I understand my application, therefore I understand what this is doing, even if they've never seen Tosca before. Then it's just a matter of pairing it up with the data that we're going to use both to drive the test and validate, which can come from a variety of sources. Our test case design, our integrated test data management, maybe an external system. We can plug into virtually any data source on the planet, and that in turn drives the system. Next slide, please. Now, what does this test actually look like? Remember I said it was very readable? This is an example of two tests, one written in Tosca, one written in Selenium, against a very simple web-based insurance application. Our founder came from the insurance industry, so it's kind of our inside joke that everything we demo is against an insurance application. But if you were a user of the insurance application, had never seen Tosca before, What you see on the left would make sense to you. I go to the inner vehicle data screen, and in each of these fields, I'm inputting this information. As you can see, I go through the insurance data, product data, and now I get down to verification. Within a table, I simply have to toggle over from input to verify. That's my test. That makes perfect sense. Think about how easy that is to maintain. And oh, by the way, if the UI change occurs, it's very simple to rescan one of those modules and it cascades through your entire test suite. And now with our AI-driven self-healing, which we're actually going to demo later, you'll see that the AI can even adjust to some of those UI changes. Now, compare and contrast that with what you see on the right. Believe me, I'm a big fan of Selenium too. There is a time and a place for it. I've overseen some very large Selenium projects. But from a readability, maintainability aspect, or even being able to identify the elements, you'll notice that XPath is being called out here. That stability, the inherent static nature of what it may or may not be using to identify the object on the screen requires a high level of maintenance. All that's being taken care of behind the scenes here with Tosca. Next slide, please. As I mentioned, it works the exact same way across over 170 different interfaces, whether it's web, Java, heaven help you, Delphi or Power Builder, mobile. I mentioned I was doing that right before this webinar. We even have the ability to reach into data sources such as PDFs, any sort of database we can connect to via ODBC, JDBC, or even COBOL. Being able to read and scan any files, or all of these packaged apps around the edges. If you were a Tosca user and learn how to use it on a web, you know how to use it immediately on all these technologies. So you have that one consistency for your automation team that not only allows you to bounce between projects, but what if your true end-to-end test case required you to touch 5 different systems in the same automated test case? Tosca is a tool that allows this to happen. Now, what happens if we run into a technology that falls outside this 170? Next slide, please. That is where our Vision AI neural optical engine kicks in. Tosca already had 4 different ways to identify objects behind the scenes. This is the 5th, and it's new and will lead to the 3rd era of test automation. I say new, it's been in the tool for a little over a year, but it was our first attempt to incorporate machine learning into Tosca, and it looks at the object identification question in a radically different way, very much like a Tesla would look at the road ahead of it to avoid obstacles. Almost like facial recognition, how the human eye would see things. It doesn't care what the technology is used underneath to create those objects, as long as it can see it on the screen. To prove our point, our Chief Product Officer, Dr. Milnick, was able to draw a picture of a login window on a napkin, take a picture of it with his phone, Slack it to himself. He used that X scanner I showed you previously against that JPEG, and he built his automation model with username, password, OK button, dropped it in a test, pulled up the LinkedIn production login window, and it ran because it's adaptable, it's adjustable. So you can create automation earlier against wireframes, against PDFs. We've been able to automate across Citrix interfaces, RDP hops. I even automated across a Zoom call once. And now that we've incorporated a level of self-healing, which we're actually going to demonstrate later today, this has become even more and more powerful. So think of this as the 3rd era of test automation. Next slide, please. Speaking of demos, I think we've queued it up. I want to show you some of the latest and most wonderful features within Tosca with the help of my colleagues from eInfoChips. So at this point, I'm going to hand it over, and we're going to talk a little bit more about Vision AI, as well as self-healing and some other aspects at the API testing level. Thank you.
Thank you, Shami. So in this demo, we will see usability and benefits of working with Vision AI. With Tosca 14 and above, Vision AI allows you to automate UI-based test cases, including cloud-native applications, remote desktop applications, and design mockups before any code is written, enabling you to test much earlier in the development lifecycle, that is, shift-left testing in Agile. So it is an AI-driven UI automation engine. So some of the prerequisites that are required to run Vision AI, that users should have an account at Tricentis Cloud Platform, and once Tosca is installed, Vision AI is part of the standard Tosca installation. It starts the Vision AI automatically. If it's not running, we can do it manually by going to your system tray and right-click on the Vision AI agent to connect with authenticated Nexus server. Few features of Vision AI is part of a standard module under T-Box engine, which we'll cover later in the demo, like self-healing AI. So without waiting further, we can start with the demo. So here we are creating a new folder. Let's say we can create a Vision AI and Vision AI is part of a Tealbox engine standard module as well. So here you can see an image of a design or a mock-up, like that's how UI product team has decided like how the application would look like. So what we can do is we can simply scan this mock-up or a whiteboard design by right-clicking on the context menu and selecting Vision AI and scan the mock-up. This could be a PDF or image or anything like a whiteboard design or any PNG file. In XScan, we can select the objects by using select on screen. And even if it's an image, it will identify the control type. As you can see, it has identified the calendar, radio buttons, drop down, input, and next button as well. Just based on a mockup and an image. No technology involved, no language involved, a complete whiteboard design. So that's how Vision AI works. Even if it doesn't detect the control type in XScan, we can change it in the properties of the module. So here we can rename the control type that we have defined, rename the objects that we have defined. Let's say one of the object that we have identified, the property, it's saying input, but actually in the mockup or the live application that we are planning to develop, the control type is dropdown. So we can simply go to the properties, load all the properties, and there's a parameter called as treat as. In the treat as parameter, you can see that there are different options to change the control type. It can be a table, it can be a drop down, an input button, checkbox, or anything. So based on that, we can change the control type. We can rename this module as per what we like. Let's say vehicle insurance, photo, or whatever PDF is available. And we can save this module. So here you can see all the whatever objects we have defined, all of it's available with the correct control type. What we can do, we can simply create a test case out of it by selecting a new test case folder that we can create, like let's say Vision AI. And we can drag and drop the module that we have just created. You can drag and drop the module by either dragging it from the modules folder or you can search for the particular module. Once done, we can just fill in the value for each of the object type in the test case. And once done, we will simply run the test case against this mockup. That's just an image. So here we can see the test case is running successfully. It has identified all the control based on just a whiteboard design, no technology or no language involved. And you can see once done, the test case result will say that the test ran successfully just by identifying the objects in the image or a mockup of the application, even when the application is not available. So that's how Vision AI works. Even when the live application is not available, shift left testing can be done much earlier in the development lifecycle. Now let's say the live application or the UI is ready. As we can see, this vehicle data based on the mockup, we can say that, okay, UI is ready, everything is ready. So the first question that would come up in the mind is whether test cases, old test cases that we executed on the mockup of the application will work here. So the answer is yes, that's the purpose of Vision AI. So what we can do is, based on the caption of the application or the web application, we can just update the caption in the module. And without modifying, rescanning the modules again or changing any property, we can run existing test case on the live application. So here we are running test case against a live application. We haven't updated anything in the test case. We have just changed the caption in the module based on the web application that is available. And you can see that it will start updating values in each and every field, whether it's a calendar, it's a drop down, it's a radio button, input field, or it's a click button. So my automation, you can see it works immediately. I didn't have to create any script. We can directly execute this script. Even if we have upgraded that, let's say different technology in the background, these script will still run. So that's how Vision AI works. But let's say if developer has created an exotic tool, different language, different technology. So what we can do? Here we can train Vision AI. Let's see, you can see there's a table with div elements. So what we can do is we can simply create a new module Let's name it as UIDC, that is user identified control. Scan this exotic application that the developer has created. So the table here is built out of div elements. That's a modern way of HTML. It can identify the rows and columns, but there could be a case where it is not able to identify the whole table. So what we can do is in Xscan, we can create UIDC by right-clicking and selecting the Create User Identified Control from context menu. We can train Vision AI to understand that we need to identify such objects. So once done, what it will do is it will open a new window where using anchor method, we can ask Vision AI to identify a particular table or drop down or checkbox to identify. After that, what it will do is it will scan your window. Okay? We can draw a box around the object and we can choose an anchor for the object. In the control name, we can name the object whatever we want to. We can select the control type, whether it's a table, it's an input, or it's a drop down, radio button, checkbox, menu, icon, anything. So in our case, it's table. Take it as table. Application, in our case, it's HTML. So once saved, when these changes are done, it has once saved, Vision AI will look into your screen, recognize object like, hey, this is a table. It will do a quick rescan of the same table that we have just created. For Vision AI, we have just trained. So it will say, okay, you can just scan the screen again. You can select the table by right clicking like, okay, this is a table that we just created right now. And Vision AI will be like, okay, hey, this is a table. Let's do a scan. These are the headers. These are the rows. These are the cells. And without doing any coding, etc. It recognizes the object of the table. And then we can select that. And in the scan, you can see all the columns and rows. Once done, you can save the module. It's available. Also, whatever UIDC we are creating, it is saved in Vision AI home website as well. So from here, you can delete or reactivate UIDC. The control is not deleted permanently, but move to deleted items selection once where you can activate it again. So that was all about UIDC and Vision AI, where we can train Vision AI and also perform shiftless testing. So moving to self-healing. Let's say one of the interesting part of Vision AI is self-healing AI. Vision AI allows you to enable self-healing of every control that can't be found when you run your execution list. It focuses on UI layer of an application. It continues with an action when tests break, like retry, resolve, or use a different case. It is right now available for web-based automation of web application, and right now it is planned for mobile applications as well. So let's see how we can use self-healing AI in our falling, one of the failing test cases. So what we can do here is you can see we can have a module created for vehicle insurance app that we just tested earlier for Vision AI, and test cases also created for the same. And self-healing AI comes as a part of T-Box engine. Let's say we have this test case created already, and we have run this test case multiple times in execution where it was passing, and it's a standard part. So that's one of the prerequisites of self-healing. We should have test case executed in an execution list, and past results should be available. That is, test history should be stored on the cloud. Here, let's say we have changed the next button. The UI changed, the label has changed, or the color or location of the button has changed. Okay, so that's when the self-healing AI will kick in. It is able to detect adaptive object by comparing a baseline detection with the subsequent detection using machine learning. So enable self-healing AI, we have to add a recovery scenario. And the property tabs or recovery scenario, we have to change the retry level to test step value, and use a module self-healing AI under standard module to create a test step in the recovery scenario. And we can add a test configuration parameter as well, that on dialog failure and test step value retries. So let's run this test case from execution list and see how test case is failed, but Vision AI, self-healing AI kicks in to identify the changes. So here the execution list was running successfully because it was able to identify next button, but now the button has changed to continue. So here you can see it will look for next button, which has been updated to continue button. So it is going to look at your previous runs and have full certainty that based on my previous identification, I'm almost confident that I'm going to stay continue button instead of next. So it can take almost 1 minute as well. So here you can see that the test have failed for next button. It couldn't find the next button. But after that, self-healing AI kicked in where it identified based on previous result that next button has been renamed as continue button and our test cases are like passing. So that's our magic of self-healing AI. From my side, it was all about self-healing AI, how it works for changing UI and how it helps to fix the failed test cases. So now I would like to invite my colleague Gaurav to talk about API testing. Over to you, Gaurav.
Thanks, Konika. So now I would walk you through how we can automate APIs using Tosca, how Tosca's model-based test automation framework helps you in speeding up your API test automation. For that, Tosca provides you with API scan. It's inbuilt tool, which looks like a postman, which is a ground for creating your manual test and getting them into a Tosca commander for the automation. Along with that, we will create few API test cases and see how Tosca's inbuilt feature like configuration parameters can help us reduce the maintenance in the future. Also, Tosca's inbuilt feature like templates and test sheets that helps you include data-driven testing with your API test automation. So let's get into the demo. Can you please resume? Okay, so here we are using API from Tricentis. That is a demo coffee web shop. So it just tries to create a coffee using API and try to get it. So this is API scan, which you can trigger it from Tosca commander. It opens it like independently and you have different menus for that as you see at the top. Here you can import a Swagger file, right? You have to give the Swagger URL and then you get all the APIs inside Tosca API scan. Here we can see different API calls like post, put, get. These are present here. Once we have it, then we can run it easily at the run button right top you can see and gives you the result. So here we ran the get API call and we can see there are different coffees which are present in the database have been like retrieved. So this way, similar to Postman, you can do all these things where you can change the values and run it here as well. So now we are trying to automate this post call. Here a couple of parameters are there which we are trying to change, that is description and name. When we run it, it will try to create a new coffee using post method. Here you can change it post endpoint as well as resources as you need. Once you run it, a new coffee would be created. That's your response with a new ID. So you have it present here. Once you have this, let's say we want to find out this coffee has been created. So we'll go to the get API call and check, okay, do we have this coffee along with the ID, which is 10. Once you run it, you can again select different methods, endpoint and resources. Once you run it, you have the results. That's your status code 200, okay, success, and you have the correct response. Now let's do the automate this particular post call which we did run. So we already have this coffee created with ID 10 with request and response. Now it's just what you have to do is there is an option at top API test case, right? You will click there, you will go to the API test and export. Now the export is to the Tosca commander, right? So we are back to Tosca commander where you see two modules have been created, that is request and response, that's standard for API with this particular technical view. And also a test case has been created with two test steps, that is request and response. Now coming back to module, so we just have a raw module. Now you need to parameterize it. You can have a different method, endpoint, or the attributes for that particular module, so that in future when you use this module, when it's parameterized, you can have a different data sets for the particular module. Same we can do for the response, right, where you would want to check that your status code is fine so that you can check if the API ran successfully or not. Similarly, if for this particular API, it's ID which would be required to see if the coffee has been successfully created in the system. So now our modules are ready. As you can see on the right side, there is a value range. Those are the values which are we used when we ran the API manually. So Tosca automatically recognizes them. And when you go to test case, you can just click on the drop down in value and you select these values. In case you want to add more frequent values, you can add to value range and you have it present in the drop down. So again, here you see all the parameters attributes created. You just have to go to drop down, use the static values if you want to. If you want to change them, you can do that as well. We are using the old value. Now let's say we want to change it, put something different. So we are adding that. Similar is the case for the name, right? Once you have request created, you would go to the response. You would want to check, okay, my status code, what is that? It's 200, okay. In case your test case fails, right? So you would see that it's not 200, okay, and Tosca would also tell you what is the status code. So you can debug the issue if there is something in the API. So again, this API is returning description and name. You would want to verify that in the response. And ID is something that is new coffee has been created. I would want to store this ID somewhere, right? Tosca's action mode makes it easy for us. That's coffee ID that has been stored with my API response, and I can use it whenever I want to later. So now we'll run this in a scratch book. That's like a temporary run provided by Tosca that gives you trial and error, and it also gives you temporary results. So here we have successful request and response. Request would be just okay, but response, you see status code has been successful, 200, okay. Expected values and actual values are matching for description and name. And here coffee ID has been stored, like coffee ID buffer has been stored with value 11. That's our new coffee. So this is how you can easily automate API using Tosca's model-based test automation. No code, nothing. You just have UI. You have drop down to select the values, and it's very easy to search and find it out. Now, as you saw, we had description and name similar in request and response. So that was used kind of twice, right? So Tosca provides you with configuration parameters, which can help you define recurring values in your test case in a variable. So for example, here variable is description, and second variable I'll define as like name. So I would put these particular values inside that description and name. And if you have recurring usages of these values, I would use this configuration parameter. So that right now it's American coffee and its name is, let's say, latte, or we are going to change it. So in that case, in future, if you want to change it to something different, you just change it at one place and then it will be reflected all across test case. It's easier for a two-step API, but if you have a lot of steps, or if the same variable has been used across a lot of, let's say, API calls like post, put, get, right? So you can just define the configuration parameter, put the values, and then put the syntax. So next time, whenever your test case changes or ask for a data change, you just change it at the root level for the configuration parameter, and that reduces your job a lot. Similar thing if you want to do in Postman, it would take a lot of time. You have to open different saved API calls in like post, put, git, delete, all these things. You go change and then check it. Here you just do it once and boom, your work is done. That reduces maintenance a lot. And the next feature we are going to look is the template. This is very important feature of Tosca, which helps us in going for a data driven testing. We can test a lot of data using templates. So basically templates is when you have similar flows, you want to pull data from sheet, something like Excel, right? And attach that sheet to a test case and create the test case as and when you want. So here you just create a template that's just a normal test case, but you create it to template, you add some test steps to that, and then yeah, this convert to template. And now your next job is to attach the data sheet to that. Before that, we are just adding the different calls which we want here, right? Status code, which are going to be static. So these values we are adding. Dynamic values are description, name, which can be added from the sheet. I said Excel, so kind of inbuilt as Excel Tosca provides that test sheet that sits inside Tosca, reduces your efforts a lot. So here I have three different types of coffees, right? With description, name, and coffee IDs, which can be stored, right? So this Excel sheet or test sheet can be easily attached to template, right? Just drag and drop. Once that is done, now you would want to pull the different values for description and name. Again, it's easy. You just drag and drop that particular attribute of coffee and it will automatically create a syntax for you. Similar way we would do it for response. And once that is done, your template is kind of ready. Your sheet is attached. You have correct syntaxes on value section in Tosca. You set correct action mode buffer because we want to buffer the coffee ID, same what we saw in the post call. And once these things are ready, you'll just check for template. It gives you that, okay, if there are any errors or not. Right now, there is none. So now you'll go for instantiation. So you will create different test cases, right? So as we had 3 coffees, you have 3 test cases created. So just imagine if you have like hundreds of data, what you need to do is just add it in a sheet and you will have 100 test cases that would be created like in an half an hour, right? If you have to do that manually for this much of data, you would be spending, if not weeks, at least days, right? So that's really accelerated testing, and that is going to save you a lot of effort. So here we are using Tosca's feature execution list where actual logs are stored. So here you just have to drag and drop your template instance. And as you see, these 3 test cases would take just a couple of seconds to run and you would have your results ready. So that's really easy. I mean, whatever number of instances you increase, it would take very less time. And as you see, different coffee IDs, different description have been verified successfully, buffered successfully for all the test cases within moments. So this is the way Tosca will help you to test a lot of data. Again, these test sheets provide you with a lot of options. Once you create a test sheet, you can ask Tosca, okay, give me these combinations. Tosca provides you with different methods for like if you want to have all combinations of, or if you want to go for just bare minimum that like covers your most of the risk. So you can do that. So Tosca really helps you increase your risk coverage. At the same time, it helps you to reduce your creation and maintenance efforts. And as you saw, this does not require any specific coding language or anything. So you can get train anybody as quickly as possible. So we are saying on all fronts, training, creation, maintenance, execution, all fronts, Tosca is helping you accelerate your testing and get ahead with your project. I think that is all from my side. Thank you.
Thank you so much to all our panelists. We've got some questions lined up already from our audience. And if you have any more questions for all of you attending today, please type them into the chat box and we will take them up. Starting off with the first question, how can Tosca be used in IoT?
I can take first stab at that one. Normally, when we're talking about IoT, I normally see it from a performance perspective, but we can definitely do functional testing as well. And what comes to mind is I've been involved with a warehouse system upgrade project for a customer down in Orlando where they have a lot of handheld devices. So it's really perfect IoT scenario. And what we typically find is those protocols that they're using to transmit, sometimes over radio frequency, are still fairly standard and can be captured and emulated by Tosca so that we could, in essence, do 2 things. One, we can test it at the API level, simulate those request response pairs. But 2, through our service virtualization capabilities, we can actually emulate either the devices or the receivers if they're not available during testing time with virtualized responses, if you will, so that we can test it from either side. It all depends on the protocol that's used, but we support a wide variety of protocols specifically for that. And that naturally translates to doing testing at volume with our performance testing product, Neoload.
Brilliant. Thank you so much for that. We have another question. I think, Bill, you'd probably be best suited for this as well. How does testing automation help in creating a smarter testing strategy?
Overall, having automation today is almost critical, depending on the rate of change that your application is going through. So, for instance, take a mobile application, for instance, we may have releases, as you well know, on your phones multiple times a day. And having that tested as part of a DevOps or CI/CD pipeline gives you those critical quality gates to make sure you know you're deploying with confidence and not having to deal with production outages. So automation is one of the cornerstones to continuous testing, which feeds directly into a DevOps strategy. So we could talk about it at a high level. We could talk about it at a much granular level as well. But being able to have that infrastructure in place so that you can go from idea to production and have it tested in an automated manner all the way through is key to agility and the speed of digital transformation. Now, if you have projects where you might only have changes twice a year, then you may want to take a look and decide, is it worth the investment for automation in those cases? But any place where you have a very rapid pace of change that's only going to get faster and faster, automation has to be a cornerstone.
Thank you so much. We've got a couple of questions that are more technical. Maybe Saurabh, you want to take a stab at this. The question is, there was a feature, parallel execution. Does it mean that the same test cases run on different browsers or multiple test cases running on multiple instances of web or mobile?
So generally it's achieved through DEX, like distributed execution. So, right, if you have like hundreds of test cases lined up in your execution list and you have different agent machines, right? You don't want to just run on one machine, it's overhead. So Tosca's DEX generally distribute it across the different machine and you can get the collected results. Yeah.
Thank you. We've got a follow-up question on that. How can we run API or web-based test suite on different test environments?
So basically, again, this can be achieved using DEX. So when you have DEX and you can set up your configuration on Tosca server, you can set up different DEX agents on your agent machine where you want to. For example, there are like 3 machines. So you set up this DEX agent that comes with standard Tosca installation. Once you have it ready, on any machine, you can have your test event created in the execution list, and this test event comes with a specific configuration, right? So you can specify the configuration of that agent where you want to. And once the configuration is specified for this test event, when you run it from anywhere, this request will go to the server and server will direct to that particular distribution agent. And on that agent, your execution will start. So if you have different configurations that you can do, of course, in Tosca and its execution list, you can assign it to that execution list and that will be passed on to different agents.
Thank you so much. We've got a couple of questions on Vision AI. The first question is, how does Vision AI work with model-based test automation?
I can tackle that one as well. Vision AI actually creates models just in using a different driver. So you would still see a model artifact within Tosca. It's just using that neural optical engine to create it. And therefore you would still build your tests in the same manner. Whereas our typical T-box models are built with your more traditional identifiers on the technical side. The Vision AI models are built with that neural optical net that is interpreting things as a human eye would see it. But both approaches still result in models that you drag and drop in the test cases.
Thank you. We've got a fairly technical question here. The question is, can we integrate test case management tool? Example, I have my test cases in Jira and we have created test cases in Tosca. Can we update the test results in Jira after execution?
Oh, the answer is yes. You can absolutely integrate Jira directly with Tosca. There's a number of ways to do that. Typically, what we synchronize between is the requirements module of Tosca to Jira as well as the defects. Now, there are other integrations if we involve our product Q-Test that allows you to be even more flexible in that regard. In fact, I always recommend that if you are a Jira shop, Q-Test is the ideal test management layer between Jira and Tosca. In fact, our friends at Atlassian who make Jira use Q-Test internally to test Jira. It has the industry-leading integration. And combining those 3 platforms is definitely the most powerful option, although you can combine Jira directly to Tosca if you do not have Q-Test.
Thank you so much, Bill, for that. There's another question on Vision AI. Would self-healing kick in if the properties of the UI have changed?
So the answer is no, because self-healing actually works in the UI layer of the application. So something like the label has changed, the color or the location of the button or something has changed, then only it will kick in. But if the properties of the entire specific object has changed, then in that case, self-healing won't be able to help in running that test.
There is a gray area there, though, as well, because when I do my self-healing demos, I do change multiple properties. But to my colleague's point, it depends on exactly which properties you're changing. If you're changing something from, say, a drop-down list to a multi-column table, it might struggle with that. But if you're changing the label or color of a button, for instance, or even some of the technical identifiers under the covers that aren't necessarily visually related, the self-healing will still work. And as we showed, there's actually two different approaches to self-healing right now in the tool. One with our T-box engines, which is far more reliant on specific technical identifiers, and you actually use a neural network and you have a range of tolerance about how those identifiers could change. And then the Vision AI, which takes that more visual-based approach, so a completely different approach. But both self-healing mechanisms are currently built into Tosca 15.
All right, thank you so much. I think that's about the time we have for today. If you've got any more questions, do feel free to get in touch with any of us and we'd be happy to answer your questions. And thank you so much for being here with us this morning. I'd like to extend a very, very warm thank you to all of our panelists for taking time out and sharing your insights with us, and wishing everyone a fantastic day. Thank you so much.
Thank you, everyone.